Okay, so this is the last section in chapter 12, and it's on relative motion. Okay, so we've all seen that when we describe motion with one frame which is fixed. So I'll call that frame OXYZ, shown over here, and then there's a frame A which is actually moving, and I'll tell you what that means. And then we're trying to keep a track of particle at B. Let's call this to be a particle which we want to keep a track of. We can keep a track of particle B in two ways. One way is we find where that particle is with respect to a frame O which is fixed, or we could keep a track of particle B through A and O. So we know how particle B moves with respect to A, and we know how A moves with respect to O, and knowing those two things you can also find how particle B moves. So those two things are related by this formula, where RB is the position of particle B with respect to frame O, RA is the motion of A with respect to O, and RB with respect to A is the motion of B as seen by A. Okay, so the easiest way to think about this is O is like a frame which is fixed, say, to this room. Okay, so X, Y, Z originally, and that frame is fixed, it's not going to move. B could be, say, one of you, okay, and A could be me. I'm actually moving. As I'm moving, I'm observing you. So I can keep track of you in two ways. One is I can find where you are located with respect to that fixed frame. So that would be B with respect to O, or just simply written as B. Or if I know how I'm moving and how you are moving with respect to me, then I can also keep a track of you, knowing those two things of pieces of information. One is how I'm moving with respect to that frame, and how you are with respect to me. Okay. The typical application is if you are thinking of how things are moving in space, usually planets, then if you can keep a track of one planet with respect to another, then you can then start figuring out how a different planet, let's say, we know how the Earth moves with respect to the Sun, and we want to keep a track of how Mars is moving to Earth. So if you can always keep a track of how Mars is moving to Earth, okay, keep a track of that, and then we can find how Mars is moving with respect to the Sun. If we pretty much know how Earth is moving with respect to the Sun and how Mars is moving to Earth, okay. So in this case, Earth would be A, it's moving, Sun is fixed, and Mars would be B. Okay, it's just a different way of keeping track. Sometimes it's easier to keep a track of movement relative to B with respect to A than it is to keep track of everything with respect to an origin. You can take this formulas, differentiate with respect to time, and find velocity, which is basically the rate of change of position, and then differentiate with respect to time again to find acceleration, velocity and acceleration. Okay, I think velocity is the easiest to understand. Acceleration just follows from this. So if you thought that was hard to understand positions, velocity might be easy. So what's velocity of B equals velocity of A plus velocity of B with respect to A. So you can think of two cars which are traveling at the same speed. If two cars are traveling at the same speed, okay, one car, call it A, the other car, you can call it B. If both those cars are traveling at the same speed, then the velocity of B as observed by a person in A is going to be 0 because both of them are moving at the same speed. Okay, that's the interpretation of velocity of B with respect to A. Now, if you want to keep a track of B when both are moving at different speeds, then, well, if you keep a track of A and you know how B is moving with respect to A, then you can keep a track of B by knowing that A is moving, let's say, at 2 meters per second with respect to a fixed frame, and B is moving with 1 meters per second with respect to A. Then you can keep a track of how this car B is moving with respect to A, knowing two pieces of information: how this is moving to this, and this is moving with respect to a fixed frame. So that's another way of thinking of this formula. Okay, so well, we'll solve problems and see how you can use these formulas to sometimes simplify solving problems involving two particles moving at different speeds. Okay, so hopefully this will make it clear when you solve problems. So two boats leave the pier P at the same time and travel in the direction shown. The velocities are constant as shown in the figure. So velocity of A is 40 feet per second, velocity of B is 30 feet per second. They're traveling at 45 and 30 degrees as shown. Find the velocity of boat A relative to B. Okay, what this is asking is to find velocity of boat A with respect to or relative to B. That bar represents relative to, and the time when they are 1500 feet apart. Assume t equals 0 when both boats are at P. Okay, let's solve the first part and then we can think about the second part. Okay, so we want to find velocity of A with respect to B. Okay, so we can write, well, we wrote the formula as, if you turn back, we wrote velocity of B is velocity of A plus velocity of B with respect to A. Okay, do not change the order of that formula. It is this what it is written down there. Don't write velocity of B is velocity of A plus switch the A and B. Okay, if you want to this formula doesn't quite tell us how to find A with respect to B, but it's actually quite simple. If you switch the A and B, you'll basically switch the sign. So if you want to switch from B with respect to A to A with respect to B, then you just simply switch the sign. Okay? Or in other words, another way to write this is velocity of A is velocity of B plus velocity of A with respect to B. Okay, so this is an unknown. If we can find velocity of B and velocity of A, then we can plug in those values and find A with respect to B. So let's try to solve for velocity of A. Okay, from what is shown over here. So A is traveling at 40 feet per second at an angle of 30 degrees with respect to the y-axis, or it's traveling at 60 degrees to the x-axis. So velocity is the magnitude, which is 40, times the component in the x direction. So it's going to be cosine of 60 degrees times I plus sine of 60 degrees times j. And it's all positive because A is moving in the first quadrant. It's directed towards positive x and positive y. Similarly, velocity of B is the magnitude, which is 30, times cosine of 45 degrees I plus sine 45 degrees j. So now we can plug these values in here, in this one. Velocity of A is 40 cosine 60 degrees I plus sine 60 degrees j equals 30 cosine 45 degrees I plus sine 45 degrees j plus VA with respect to B. So you can easily find A with respect to B. You got to find the I component and the J component and then subtract the two. So VA with respect to B is minus 1.21 I plus 13.43 J. Okay, so part 2 asks us to find the time when they are 1500 feet apart. So note that they both start at P at the same time and they travel at different angles. Okay, so when they are traveling at different angles, clearly the distance between them is going to grow. Eventually it will be 1500 feet. We need to find the time at which the distance is 1500 feet. Okay, so one way to do it is we know the velocity is constant, so we can find where B would be at time, say sometime t equals t. We can also find the position of A after time t equals t. We know the x and y position in terms of t. We can then subtract the x and y coordinates right? To find the Euclidean distance. Euclidean distance is basically the difference in the x component squared plus difference in y component squared, and you take the square root sign, and then solve for time. So that's I would say, the harder way to solve the problem. The easier way is, we know the relative velocity of A with respect to B. We can use that relative velocity to solve this in a much easier way. The distance between the two, I'll call that A with respect to B, is simply velocity of A with respect to B times the time. So this is the formula. The distance is velocity times time if the acceleration is 0, right? Constant velocity. So SA with respect to B is 1500. Velocity of A with respect to B, magnitude, is going to be the square of 1.21 square plus 13.43 square times the time, which is the unknown. So if you solve for time, you get 111.26 seconds. Okay, that is, in that much time, the two boats will be 1500 feet apart. Okay, you could, as I said, you could solve it in a different way. You could find the position as a function of time first for the two boats, and then subtract the x and y and do it that way. Yeah.
The equation that you use, that SAE, whatever,
Is what? It's a kinematic equation. Distance is velocity times the time.
And that's just when acceleration
Is 0. Mm-hmm. Any other questions? Okay, so let's see if we can do this. Car A is traveling with a constant speed of 80 kilometers per hour due north, as you can see. Car B is traveling with a constant speed of 100 kilometers per hour due east. Determine the velocity of car B relative to car A. Okay, now it's going to be hard for you to poll this answer. So what I'm going to do is, I'm going to ask you to give me the answer for the magnitude of velocity of B with respect to A. So first find velocity of B with respect to A, and then find the magnitude, and just poll the magnitude. Okay, poll this answer. So first, write the formula for velocity, relative velocity. Find velocity of A, velocity of B, and then find the magnitude. Okay, so before we solve this, we need to set up a coordinate frame. So let's choose a coordinate frame like this. Okay, if I'm not given you a coordinate frame, you can choose it any way you want. This is the most intuitive one. So let's write the velocity of A. So A is traveling north. So its magnitude is 80 and its direction is positive j. B is traveling at 100 kilometers per hour. It's traveling east, so that's going to be 100I. And so velocity of B is velocity of A plus velocity of B with respect to A. And so velocity of B with respect to A is velocity of B minus velocity of A. So velocity of B is 100I and velocity of A is 80J. We are interested in the magnitude, so velocity of B with respect to A is 100 square plus minus 80 square. So I got 128.1 kilometers per hour. Okay. Okay, so that's right. Okay, any questions on that? So that's very straightforward, right? Here is another problem. Okay, this one is slightly more involved because you're not given the angles directly. At the instant shown, car A is traveling on the straight portion. So by the way, it's traveling this way at the road at 25 meters per second. So 25 meters per second. At the same instant, car B is traveling along the circular portion of the road with a speed of 15 meters per second. It's also traveling this way. Find the relative velocity of car B relative to A. So velocity of car B relative to A. Okay, you can actually manipulate the formula I had written down earlier to write velocity of B with respect to A is velocity of B minus velocity of A. Okay, that's just taking the formula and moving things slightly around. This actually is an easier way of to remember the formula. B with respect to A is simply velocity of B minus velocity of A. Okay, so let's try to find velocity of B and A. The easier one is A because we are given that it's at 30 degrees to the horizontal. So A is traveling at 30 degrees to the horizontal this way. And so X and Y is given here. So what I'm going to do is write the velocity of A as 25, which is the magnitude. Okay, now I need to write the components in the X and Y direction. So it's important to note the direction of movement. A is traveling in this fashion, right? So I need to resolve it along the I and J. So the X component is going to be clearly cosine of 30 degrees. Okay, and this arrow points in the positive I direction when you resolve it along the x-axis. So this is going to be positive cosine 30. For the J component, when I resolve it, I get sine 30 degrees along J, but the direction is going to be in the negative J direction, so it's going to be negative. Okay, let's try to find velocity of B. So B is at 15 degrees. So if you draw a tangent here to the circle with rho equals 20, then this angle actually is also the angle made by this line with respect to the vertical. Okay, that's a property of a circle. So this angle is 30 degrees, 15 degrees. Same as the angle made by so I'm saying is if you draw the tangent here, then this angle, whatever it is, phi, is the same as the angle over here. Can you see that? So what we can do is we can draw a figure similar to this one. With b at going at an angle of 15 degrees. So the same reasoning. So I would have the magnitude, which is 15, times cosine of 30 degrees. So it's going in the same direction as A. So it's going to have the same sign. So positive cosine 15 for I and minus sine 15 degrees for J. So we can put that in one. And solve for velocity of B with respect to A. The answer is minus 7.11 I plus 8.62 J, and the units are meters per second. Any questions? It's clear? Very straightforward, right? You have to essentially know how to find velocity, resolve velocities in the I and J direction. No questions? Okay, so cars A and B are moving on a circular track as shown. Missing here. Car A has a speed of 90 feet per second. So A has a speed of 90 feet per second and is increasing its speed at the rate of 15 feet per second squared. So V is 90 and 15 feet per second square is its acceleration, or V dot. Whereas B has a speed of 105, so B has a speed of 105 and in decreasing its speed at 25 feet per second, so V dot is minus 25. Determine the relative velocity of A with respect to B and relative acceleration of A with respect to B. So relative velocity of A with respect to B, as I said, the easiest way to write this is velocity of A minus velocity of B. Okay, so we need to only find the velocity of A and B. So velocity of A, okay, A is at the apex of the circle. It's traveling in the negative x direction, so its speed is going to be magnitude, which is 90, times I. So that's saying it's in the x direction, but it's moving in the negative x direction, pointing that way. Our x-axis are positive to the right, so this is going to be negative. Velocity of B. Okay, B is traveling at a tangent. Okay, so if this is 60, this angle is 30 degrees. So we need to find we can find the angle made with the x-axis or the y-axis. So this seems, the y-axis seems to be the most easiest one. Didn't quite draw this right. So B is moving tangential, so this has to be 90 degrees. Okay, so then what's this angle? What's this angle? 30. So let's see. This is 30. This is 6. This is 90. This has to be 60. And this is 90, so sum of all the angles in a straight line should be 180, so this has to be 30 degrees. Okay, with that, let's try to write the velocity of B. So velocity of b is its magnitude, 105, times we need to write the component in the x and the y direction. So let's do the x component first. So the x component is going to be what? Is it cosine 30 or sine 30? Sine 30, right? Sine 30 degrees along I. Well, it's going to be negative because it's pointing in to the left. And then the x component is, sorry, the y component is going to be cosine 30 and it's pointing upwards. So it's positive cosine 30j. Okay, so then it's just a matter of plugging in the values. You plug in the values and solve for velocity of A with respect to B. You get 37.5 I with a minus sign, minus 90.93 J. Units are feet per second. Okay, let's do the acceleration. So again, we asked to find acceleration of A with respect to B. So we need to find the acceleration of A minus acceleration of B. Then we're done. Acceleration of A. Okay, so how do we find the acceleration of A? Take the derivative of what? Of the equation. Yeah, well, we already took the derivative of A. So okay, say in other words, what is your preferred coordinate frame in which you'll find the acceleration of A? Will you use the rectangular coordinates? If you use the rectangular coordinates, what's your acceleration? What are you given? You're given velocity and you're given rate of change of velocity. So when you're given that information, you want to use the NT coordinates, right? Normal tangential coordinates, because you're given v and v dot. So acceleration is v square divided by rho u n plus v dot ut. Remember this formula from normal tangential coordinates. Now for point A, we need to find what un and ut is. Un, so un is this way, ut is to the left. So we can write velocity of A is velocity v square, which is 90 square, divided by rho. Rho is 300. Un points downwards along the negative j axis. So un is minus j, plus v dot is 15 times ut. Ut is pointing in the negative I direction, right? So negative I. So that is acceleration of A. We found acceleration of A first in terms of ut un, and then we wrote what ut un is in I and j. Okay. Next, we can write the same formula for AB. It's v square divided by rho un plus v dot ut. Note that this un and ut is not the same un and ut as A. Un and ut is a coordinate frame which moves as the particle moves. So for A, it is going to be un ut is going to be where A is, and un ut for B is going to be where B is. So I need to redraw the figure for B. This is A. So for B, un is going to point inwards and ut is going to point this way. Of course, it makes an angle of 30 degrees. Okay, so let me write v square first. V square is, let's plug in the values and then find what un and ut is, because it's not going to be as simple as the first case. So v is 105. square divided by rho. The rho is 250 un plus v dot. You're told that the velocity is decreasing, so it's minus 25 ut. Okay, the last step is to actually find ut and un in terms of I and j. Okay, I is this way, j is this way. So I'm going to try to resolve I and j, and I think just a minute. Okay, so un this is 60 degrees. Okay, so let me try to write un, relation un and I, because once I have this relation, I can plug it in here and then write the value. So un is going to be, I need to resolve I along un, so I cosine 30 degrees. As you can see over here, I resolve I along the jx, un axis, and then I have to resolve I in the ut axis, sorry, I have to resolve the j along the un axis. So that will be j cosine of 60 degrees. Now, since I points this way, it's going to be negative cosine 30, and so when I take j and I resolve it along this, it's going to be negative j cosine 60. So similarly, you can find ut. Ut is, you can use the same logic, resolve I and j along un. You get minus sine 30 degrees I minus, sorry, plus cosine 30 degrees j. Put this value here and then solve for a with respect to b. Comes out to be 10.69 I plus 16.67 j feet per second square. Okay, I'll see you on Wednesday. I'll do the review for the first exam on Wednesday.